Hello guys, welcome to Codenzyme and let's discuss this problem prime range game. And unlike the previous problem, there are some prerequisites for this one. And before watching this video further, I would like you to learn about three things. One would be game theory, and the second would be two-person game and the properties of XOR used in it. And third would be the Grundy numbers. So once you know about these three, you can continue this video further. And I guarantee you once you know about these three, you will be able to solve any game theory problem and at least understand them. Okay, so now I'm assuming that you have learned about these three, and let's continue this. Okay, so the problem statement goes like: you are given positive integers L, R and a prime number P. Consider an array A from L, L plus 1 to R minus 1 and R of size R minus L plus 1, and two players are playing a game on this array. The player with this turn will choose an index I to R from in the range of 1 to the length of the array, and a positive number x such that AI is divisible by p to the power x, and then we divide AI by p to the power x. The person who cannot make a move loses. Find the winner if the game winner of the game if both players play optimally. So here are some sample test cases, and we will try to analyze them one by one, obviously. So let's move to the pen and paper and see how it goes. Okay, so let's try to understand the first test case. We are given L, R and P, and like my L is 1, then 4, and the prime number is 2. So my array will become 1, 2, 3 and 4. Now it was said in the question that both players are playing optimally, and obviously the first player makes the first move, right? So what the first player will do is the first player will divide this by 2. So now my array becomes 1, 2, 3 and 2, right? Now the second player will, if he whatever he does, it doesn't matter. Like this is a losing state for him, like this is a winning state for 1. Right, obviously I can see that. Okay, now the second player will choose either this 2 or this 2. Whatever number he chooses, it does not matter. The second player the first player will choose and the other 2, and the second player is out of moves, so the first player will win. Like, okay, the second player can choose this and make this 1, then the first player will choose 3, 2, and then this array becomes 1, 1, 3, 1, and the second player is out of moves and he loses, right? So that was the explanation for the first test case. I will not be explaining the second and third, the other test cases. I think you get the point. Let's see the approach, like how do we solve such problems. Like obviously like if we want to solve a game theory problem, we need to determine, like every state has a fixed winner. Like it is either the winning state for the first player or the winning state for a second player. There is no like there are no chances, and both players are playing optimally, right? But how do we determine the what should I say, but how do we determine who is the winner for the current state, right? So I hope you have learned the game theory, the prerequisites I told you before, right? So let's see this test case only. Like we had 1, 2, 3 and 4, right? Now how many times, let's consider an array, another array B, and it will be like, and we are given 2 as our prime number. So I will, the elements of BI store the number of times I can divide AI by 2 or the prime number. So since I can't divide 1 by 2, I will give it 0. I can't divide, but I can divide 2 once. I can divide 3 0 times by 2. I can divide 4 2 times, right? Now so we will first construct this array now, and this is our state. Like we are at this state right now, and we need to find if this state is winning state for the first player or winning state for the second player, right? Now like I can now if I am the first player, obviously, like how is this winning state or the second state? Let's consider another state like 0 0 0 and 2. This is obviously winning state for the first player, because he can just delete this 2, he can choose a 2 raised power 2, and then he will win, right? But what if we had a winning state like 0 2 0 2? Is this a winning state for the first player or the winning state for the second player? This is obviously winning state for the second player, right? Because no matter if my first player is choosing 2 raised power 2 only, but if I have fixed that, okay, the player will choose power 2 only, okay, then this is a winning state for the second player. Why? Because there are even number of 2s here. The whatever my first player chooses, the second player can do the opposite, right? I hope you get the point. Like from L to R, okay, if a power of 2 occurs even number of times, if a power of 2 occurs even number of times, that will not contribute to my answer, because the second player can choose the another state and make it back to the current state, right? So obviously let's say my array B is something like 1 0 2 1 2 4, let's say 3, then 1 again, right? So I can say that, okay, my 1 occurs 1 2 3 times, so it will contribute to my answer, but my 2 occurs only 2 times, so it will not contribute to my answer. Like if the first player chooses to delete this, second player can again choose this, and then it is back to the to this state, right? This is similar to 1 0 0 1 0 4 3 1. That is what I'm saying. Like if I have if the current state is the powers which are occurring even number of times will not contribute to my answer. That is all I'm saying. I mean, I think I hope you were able to understand that. If not, you can comment down the description and I will try to reply you. Okay. Okay. So first, what I'm doing is, if I have an array B, I have an array A, I've converted, I've created another array B, such that I'm finding out what is the maximum number of times I can divide AI by the prime number, right? And after this, like if you have studied game theory, if you know about the zero sum game, then you should and then it should strike you that the answer will simply be the XOR of B. Just take the XOR of all these elements, and that will give you the answer. That will give you the current state, the winning state, right? So if you take the XOR of all these elements, if the if the XOR is 0, then the second player is winning, because the elements are occurring even number of times. Whatever the first player does, the second player will do the exact opposite and bring the game to the normal state, right? So the XOR will be 0. And if the XOR is not equal to 0, then first player is winning, right? But there is a problem in this, that this will computing the XOR, like first we will have to make this array first we have to make this array A from L to R, and then we have to convert this to array B. That will take like some login time for base P time to convert this, and then taking the XOR, that is taking really long time when L and R range to 10 to the power 18, right? Like if you see in the constraint, the L and R go to 10 to the power 18. We need to some and our array is like L plus 1 till R minus 1 and R. So we can't make an array of 10 to the power 18 length, right? And we need to find the number of times p raised to power 1, p raised to power 2, and p raised to power I don't know how much will come in this array, right? So how do we find it? Like if you see the obviously 10 to the power 18 is almost 60 bit number, right? So it is obviously less than 2 raised to power 60. And now prime numbers which are greater than 2, so I can say that maximum prime number power of 60 will occur. Otherwise till only till 60 I have to check, and rest I can ignore. Like I have to check how many times p raised to power 1 occurs, how many times p raised to power 2, till how many times p raised to power 60 occurs. I can leave the rest of the powers because they will never not be occurring in this range till 10 to the power 18, right? So that is the case. Now first I have to compute how many times p raised to power k occurs. Now how I can find it, how many times p raised to power k occurs? Now here you need to learn about this concept used in range db. So if you want to find out p raised to power k, how many times p raised to power k occurs in L2R, right? So so there is this formula like r upon p raised to power k minus L minus 1 upon p raised to power k. Well, this will basically r upon p raised to power k gives you the number of multiples of p raised to power k in the range 1 to r, and L minus 1 upon p raised to power k will give you the number of multiples of p raised to power k in the range 1 to L minus 1. So if you I mean subtract these from like r to L minus 1, this will give you the number of multiples of p raised to power k in the range L to r, right? Now obviously this will contain the higher powers also, because p raised to power k is not like the only powers. It will contain some higher powers, so I will have to divide by p raised to power k plus 1. I have to subtract the higher powers power multiples from this, right? Minus L minus 1 upon p raised to power k plus 1. Like I have to compute this for every k, for k equals to 1 to 60, like for every prime number I am given. And once I have this, I have to take the XOR of all these XOR of k values, and then I can do it, right? I mean, I hope you were able to understand my approach. Like I will just show you another test case, and I think you will be able to understand this. So we have 10, 20 and 2, L, R and P, okay? And the winner of this game is first player. Let's see how. Like first I am given an array A, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Now I want to find out for every element, let's say how many times how many times can I divide this array by 2. Like if I do that, then I can divide 10 only once. Then obviously odd numbers I can't divide. I can divide this 2 times, 1, 0, then 2 raised to power 4 is 16, 0, then 2 into 9, so only once, then 0, then 2, right? So I can say 2 raised to power 1 occurs 2 times, 2 raised to power 2 occurs 2 times, and 2 raised to power 4 occurs 1 time, okay? Now let's try to compute it with using the formula. So if I divide 20 by 2 raised to power 1 minus 9 upon 2 raised to power 1, and obviously take the GIF of them, GIF of that. So this is like 10 minus 9 by 2 is how much? Like it is 4.5, so 4, which is 6. Now obviously the answer is not 6, because it is containing all the multiples of 2 raised to power 1, right? If you see, like 2 plus 2 plus 1. So from this I need to divide the higher powers. So just consider the multiples of one more power of 2. So like 4 minus 9 upon 4, and if you do this, it will give you like 5 minus how much, like 2, which is equal to 3, and 6 minus 3 is, I think I made some mistake, 2.1, 4 5s are 5 minus 2 is 3, 6 minus 3 actually this should be 3. Sorry about that. but okay, this gave me a 3 because I didn't count 1 here. 1 1 1. Okay, so that is how you can find so L upon R upon P raised to power k minus L minus 1 upon P raised to power k minus P upon k to the power P to the power k plus 1 minus L minus 1 upon P raised to power k plus 1, and when we subtract it we will get this number. Okay, so this is how we can find this distribution. And now, like, since we see that the number of times 2 raised to power 2 occurs only two times, I don't have to consider this. Like, I can obviously, but it is not required. Why? Because whenever I choose 2 raised to power 2, the second player can again choose 2 raised to power 2, and and it does not affect my answer, right? Like, if I choose 2 raised to power 2 here, then my second player will choose 2 raised to power 2, and the game is back to normal. So here the answer will be 1 XOR, like this is odd, right? So 1 XOR 4, which is, I don't know what what it is, like 1, then 1 0 0, 1 0 1, which is 5, and this is not equal to 0, so my first player will win. Okay, so that was the dry run of this solution, and now let's see the code. I think you will better understand when I explain you the code. Okay, so let's move on to the code. Okay, so let's see the code. I have this solve function for every test case. Now obviously I need L minus 1, so I just subtracted it here beforehand only, and I'm only considering power still P to the power 60, right? So I have made a vector to store the count of the number of times some power occurs, right? Now for every integer, like I have to do L R upon current, like this is my current power of P that I'm at, and L minus 1 upon current. And this step is important here if it is because integer overflow can occur very easily here, and if you do not deal with it here, this will give you a wrong answer, and you will be stuck on the third or fourth test case for a long time, and it will it will become a headache, right? So every time you code, you should care for the integer overflows. Okay, now just multiply current by P. I think this is standard stuff. And now if what did I say in the explanation, like whenever this will store the count of multiples of P to the power I, right? Now to find out the count of P to the power I have to remove the higher powers, right? So if for I in range 1 to 60, because this was 161, now if m of I is not equal to 0, I have to remove the count of higher powers of I, right? And now I simply have to take the XOR. And why am I doing this here? Because if my the count of power is even, then it will not contribute to my answer. I don't need to take I don't even need to take the XOR of it, and then simply take the XOR of the power. And if the XOR is 0, my answer is the second player. If the XOR is 1, then my answer is the first player. I will highly recommend you to learn about the zero sum game and the properties of Grundy numbers before watching this video, and I hope you were able to understand this problem. And if you have any doubts, you can comment down. I will also give this code in the pinned comment, the first comment in the down this video. So thanks guys for watching. I will see you guys next time.